So we're now going to carry on our conversation about hybrid and energy storage integration. This is also one of the key suppliers in the project that we heard about just before the break, which is really the landmark project for solar hybrid in the mining sector, 50 megawatts for IAMGOLD's Essakane mine. So it's my pleasure to introduce Magnus Miemoy. He is Director of Hybrid Energy Solutions at Wärtsilä.
All right, good morning. Pleasure to be here and talk about hybrid solutions. You've heard a number of presentations and discussions around hybrid solutions already, and I'm going to focus specifically on the value of adding energy storage to hybrid solutions. First, a couple of words about Wärtsilä. We're a company with super long pedigree. We were founded in 1834 in Finland, and we've been in the energy business space for a little bit more than 30 odd years. Super strong background in engines, large gas and diesel engines, where we have a leading market share, and we have delivered more than 67 gigawatts of power plants to various applications around the world. In the mining space, about 4 gigawatt in total. So many of you are customers. So in that space, we have over the years broadened our solution portfolio to also include LNG related technologies. So LNG terminals. So we call it the LNG to power. So we're able to offer a full solution, including the infrastructure needed to receive a liquefied natural gas and gasify that and utilize it as a fuel in, for example, remote places. More recently, so about a couple of years ago, we ventured into also solar EPC. So you heard from the previous presenter about a flagship project that we did together with them for adding solar to a mining application in Africa. And even more recently, just a year and a half ago, we've gone into the energy storage space through an acquisition. We acquired American company Greensmith that was already in that space, one of the leading companies in the energy storage space, and what we judge to be the leader in energy management software for these kind of solutions. So today we have a quite broad technology portfolio that we can utilize to deliver hybrid energy solutions. Still, one word about the company. About half of our business is in the energy space. Then we have just about the same magnitude of business in the marine space, in the shipping and shipbuilding space. So we sort of serve those two different industries, partially the same technology and products, partially, of course, slightly different. We are some 18,000 colleagues in the company, out of which 11,000 are in what we call services, meaning functions that support our customers when the asset is in use. And we have a footprint in more than 80 countries, so we are able to serve our customers in the locations, in the regions they operate these assets. So operation and maintenance is a rather fundamental part of the company. We're listed in Helsinki Stock Exchange. Strategically, being a company with several technologies, a broad footprint on engineering and services, we approach the market as a systems integrator. So applying these technologies, coming up with the solutions that match customer problems. Renewables, of course, being a rather new component in this and very important, as well as energy storage systems, as was already mentioned, a game-changing technology coming into this landscape of energy assets. With integration comes challenges that are maybe partly solved by engineering skills, but even more so solved by software. So a successful integration in our experience needs a very good software component to integrate with, and this is where energy management system and energy management software come very strongly into the picture. Wärtsilä's energy vision is 100% renewable. We've heard similar vision, similar strategies and statements in the context of 100% renewable mine, so this is a perfect match to how we see the energy industry at large. We've staked out sort of a roadmap of what we believe is plausible and possible for the energy industry in total. And without going into all those details, you can find our energy vision material on our website if you want to look further. But there are a number of sort of key elements. One is, of course, that the renewables are already today a very affordable form of generating energy, and they will continue to a very strong forward march. So renewables will be the new baseload. Also so for mining applications, we believe. But we also see that with an increasing penetration of renewables, there is an increased need for flexible generation in the system. So the sort of ratio of how an energy system is built up is changing, or it needs to change in order to move forward on this vision. And it also means that we have to let go and leave behind some of the old wisdoms, some of the approaches to the market that has been working in the past, but they won't work anymore in the future. And that's very inflexible, large chunks of technologies that are simply not able to cope in this anymore. Hybrids. There are many different types of hybrids, and in our portfolio we have a range of different hybrid solutions, so combining different technologies in different ways. And if I start from the top, so what we call engine hybrids, that's about combining either engines with solar, as we heard in the previous presentation, an example of, or engines and energy storage, which is another combination with slightly different values. Then we have solar hybrids, so combining solar with storage to improve the performance of solar. And then we have called them multi-hybrids or microgrid, where you combine all three. So thermal power, in our case with combustion engines, energy storage, and solar. And depending on what is the need and the application, then either one of these, they have their own, let's say, merit in the marketplace. Now, many mining applications being in remote areas, then this microgrid type of solution is maybe the one that lends itself fantastically to remote mining applications. Now, when we combine different technologies and we make a more sophisticated energy system, we need to have this glue that integrates, and this is where advanced energy management software comes very, very important. And I mentioned we acquired a company in 2017. One of the reasons that we determined that they had one of the market's most advanced energy management softwares, and we saw the role of this kind of technology in the future energy systems. Then when we look at taking steps on increasing the share of renewables for mining applications, we can get a certain distance by combining these kind of technologies, but as was a little bit also touched in the panel discussion yesterday, we can of course add other renewables such as wind, which adds yet another layer of capex to the system, or we can also start to look at alternative fuels. So biofuels would of course be a fantastic way to make thermal energy emissions free, and I'll touch a little bit more on this point later on as well. So let's look at a microgrid hybrid solution for a mining, consider a mining offtake. So the solution we're going to analyze now a little bit is a multi-hybrid that combines 3 different technologies. It combines an engine power plant, it combines a PV plant, and it combines energy storage into a hybrid system. And if you look at what does these different elements do in this system, of course we utilize fuel to be converted to electrical energy in the combustion engines. We utilize solar irradiation in the PV plant to create DC power, convert to AC power. And we utilize energy storage for 2 purposes in this application. So the energy storage addresses two issues. It does solar smoothing. So we actually manage the variation in the PV output to recapture some curtailed energy and in a way increase the efficiency. But we also use energy storage to cover for system reserves. Energy storage has been mentioned a lot during these days, and it is indeed a very, very promising technology. However, it is rather expensive today, so we have to be wise in how we apply energy storage in this kind of system. Storage is excellent for providing reserves. So the primary function here is as I said, reserves and then certain smoothing. Then when we start to size this kind of system, we need to place it in what is it doing, and this is considered as an off-grid isolated grid application. So we have to look at what is the load profile of the offtake, and it's normally not the flat curve, but it's actually a somewhat varying curve. It's got certain seasons, it's got certain variability, illustrated by this zigzag graph there to the left. And then the mission of this system is to minimize the use of fuel. Fuel is expensive, particularly if you're remote. It involves transportation cost, the cost of the fuel itself. It causes emission and all that. So the mission is really to minimize fuel. And the sizing is then looked up on a sort of yearly basis based on that load profile. Of course, the solar energy is also varying day to day. There's reasonably good statistical tools to predict that. And the right kind of sizing between these different elements is crucial to finding the right economy. There are some must-haves. So if you consider an isolated grid, we must always meet the load. We must be able to serve the load at any given minute, second of the period. So we have to have the right capacity for the load. We also need to cover reserves such that we have enough power reliability. So that needs to be considered in all conditions. And the algorithm will, in a way, look at these as constraints. So what we put as priorities and constraints, that's how the algorithm will then solve the issue. And then we're looking for what is the lowest levelized cost of electricity. So there is you could say almost infinite number of different combinations when we start to combine different technologies into a hybrid solution. So let's look at what could be the outcome of some of these combinations. So here I chose to compare 2 different hybrid solutions. So the hybrid of engines and solar to the left, and then the microgrid hybrid that also includes energy storage, such that we could get a perspective of what is the additional value of adding energy storage. So on the left-hand side, you see that against our grid load during the day in this particular, this is a single day in the year, a random day, the sun produces certain energy during the day, and we can ramp down engines running during the day equivalently. So we have to always consider then what are the system reserves, etc. And you can also see from the engine plant point of view that we would run 5 engines during the night time and the morning, and then we ramp down and then it ramp up again in the afternoon. So adding this kind of a moderately sized PV plant to the system, if you compare it to having a traditional thermal only, we can reach about 14-15% of renewables penetration. over the year, this system would curtail about 7% of energy, because there are some days where the load is significantly lower and than the particular day showed here. And over the year, in total, considering the investment costs, this would give about a 4% lower cost of energy. So it is attractive. If we would add energy storage also to the equation, we can slightly increase, maybe not so clearly shown in this particular picture because it's a day with a high load and a reasonable amount of sun, but during the year there are days of lower loads, so there's some curtailment. So we can get a little bit better benefit by adding energy storage. So what if we would do a much bigger solar plant? We saw that the solar gives us a good addition, so what about a bigger solar? And in the same comparison, we can see that, okay, we actually get more renewables on the left-hand side, but over the year we start curtailing way too much. There are so many days with a lower load, so actually the levelized cost of electricity, it went in the wrong direction by a percentage. But with storage, we can recapture some of that. But the numbers indicate that we are probably oversizing the solar anyway here with the curtailment of 25%. So the truth is somewhere in the middle. And indeed, analyzing the optimum size of solar then gives us somewhat of around 25% renewables penetration with storage and reasonable curtailment percentages and an LCOE benefit for the off-taker of almost 10%. So we can conclude that adding energy storage to a hybrid system is the next step, and it has a financial merit to do so on levelized cost of electricity. So now once we have sized the system, based on our data and assumptions, we've sized it right. Then we also need to make sure that we can actually get the benefits in reality. And this is where energy management systems come center stage. So in order to always manage these different assets in the optimum way, we need a proper and intelligent energy management system. And our Greensmith GEMS system is able to control multiple different assets. It can be a microgrid controller. It actually uses partially on-site controls, and it uses cloud computing for certain things such as, for example, PV forecasting. So we can always utilize the best available data to determine how the system will dispatch and run these assets. So in reality, the energy management system will dispatch engines, start and stop engines in the system. It will determine manage the state of charge of the energy storage, and those two assets being essentially the flexible part of the system. And the mission is to always minimize fuel by utilizing maximum renewable energy. Okay, so let me take you forward to where we are. So right there. Our Greensmith GEMS energy management system also contains an analyzer. So when we do sizing of systems, we can utilize the analyzer function in the energy management system. And that's a process which is essentially, think about it as starting with the digital plant and then doing the physical twin rather than building, engineering a physical plant and then doing the digital twin. So this is very powerful to make sure that whatever you do in the engineering stage is actually the way you're going to run the system. GEMS can integrate to any asset. Is it storage, thermal, solar, wind, hydro, and can also utilize external data such as weather data. If there is market data for a grid tie connection, that can also be integrated to the system. So, concluding, we can see that adding energy storage helps on the path to integrate more renewables. So with solar, adding to thermal, we can reach maybe 20-25%. Adding also energy storage, we can go towards around 30% renewable energy. And if we could have biofuels added to the equation, produced with renewable energy, synthetic fuels, then we could go beyond 30% renewable. The great message we have today is that we can today take the step from 0% renewable to 30% renewable for mining. So these are technologies available. And energy storage actually can be a good buddy to thermal power. We can make thermal power engines more efficient with adding energy storage. We can increase the yield from renewable sources such as PV or wind. And the energy management system is really central to making sure that we realize the benefits that we simulate on paper. And this Power to X is a new chapter in the energy industry. When with more and cheaper renewable, we can start to explore technologies for utilizing renewables to create synthetic fuels, fuels that could be then affordable enough and clean enough for remote areas such as mining applications where we today use hydrocarbon fuels. So with these components, we can take steps towards 100% renewable energy systems for mining. So, thank you.